request Dr. Mayuresh Joshi to kindly give instructions regarding our brainstorming session, which was discussed yesterday, and it was mentioned in the feedback form as well.
Okay. Hello. Am I audible? Yeah, it was a beautiful feedback form. Actually, we have got many ideas that we would like to share. Okay. First of all, I would like to mention a few ideas that we have got. The chat box is currently open for all of you to pitch in your ideas, new ideas, or if you want to say something. Also, the ideas that I'm mentioning, okay, are some of from the feedback form. We have got lots of feedback and lots of ideas also. Some of the best ideas that we found here, okay, are are what I'm pushing in front of you. If you want to say something, you can raise your hand also, or comment on the chat also. Okay. So let's begin with a few ideas. One of the great idea that we have got was from Sanskriti Almeida, Sophia College. Now her idea is using of chromatography for perfumery, okay, and vegetable extracts. Sanskriti, would you want to say something about your idea? You are free to unmute yourself and speak also. Now, in that idea, she has got a very good capacity of actually using perfumery, so extract formations, because perfumes are nothing but alcoholic, many a times alcoholic extracts. So a lot of this kind of work, okay, is being done in Vaze College perfumery department, where they are actually using chromatography, okay, in perfumery also. Okay, another beautiful idea that we got was from Priya Gupta, KC College, where she suggests the use of chromatography in toothpaste analysis, okay, and in food materials, which is again a very new idea. I'm not sure about toothpaste analysis also. I think extraction is possible, but you will need proper extractive solvents for it. So again, it's a brilliant idea for using chromatography in analyzing toothpaste. The third idea that we have got, which is again a beautiful idea, is by Rian Navalkar, she from KC College. Her idea is using chromatography for analysis of shampoos and soaps. Now, Ria, such kind of studies are being done. You can just Google out a bit about them, and you'll find out that chromatography, especially the liquid form of chromatography, HPLC chromatography, and GC chromatographies, are that is gas chromatography, are very commonly used. Okay, for analyzing shampoos, soaps, especially the texture of soaps, if they have some extracts, plant extracts added to it, and so on and so forth. We also got a very good idea from uh, Nuskar Khan, RJ College, and the participants' idea is the use of chromatography, okay, for water analysis. So what I'm thinking is from the idea the participant would want to say that to use chromatography to find out if there is some contamination in water. Yes, that can be done. That is done. Okay. Now there is one form of chromatography which is a much higher end form of chromatography. Okay, wherein microbial analysis can be done using chromatography. So what is done is that the plate that you saw yesterday, that you prepared yesterday, this now what I'm talking about is a very high-ended form of chromatography. The plate of that you saw yesterday, okay, a regular chromatography plate is run, okay, to find out if to analyze samples. This can be for antimicrobial samples also, or it can be for water samples also. After which the plate is coated with a thin layer of your nutrient material, okay, the plating material, agar plates, okay, that can be that can be anything that you use. And these plates are also incubated just to find out if there is some contamination there, just to find out if there are some antimicrobial agents there. Okay, all those things are also done. So yes, it's a very good idea, Rufkar Khan. Okay, another idea that we have got is from Shamita Naik, RJ College. Now again, I would like to say that you're free to unmute yourself, and you're free to raise your hand, or you're free to comment on the chat also about this. Okay, Shamita Naik, RJ College, shares her idea where she says that chromatography can be well used for dyes, that is analysis of various types of dyes. Chromatography is used in paint and dye industries, and also for identification of spices in the kitchen. Now, Shamita, I would actually like to see would we would all like to hear your concept about how you want this to be, used for spices in kitchen. She says that applying them in day-to-day life, okay, or for dyeing or identification of spices used in kitchen for various purposes, right? So I think your idea is does hold a lot of water here. Now there are some analysis, some chromatography papers that you will find wherein these ideas have been used also. But yes, a lot of adulteration of the spices can be prevented by developing a method that can be used for identification of spices. We also got a response from Archana Soni. Now Archana Soni, she has got a very interesting idea that she has put up. Okay, Archana, would you like to unmute yourself, because what you have mentioned on the feedback report is not that clear. But as I can see, I'll just read out what she has mentioned. She says that we can use chromatography technique with turmeric. Sorry, we would like to check commercial product. Now there is some oil which she knows, which claims to have 7 oils in it in one. So yes, with the chromatography, you can actually check if their claim is true. Archana, would you like to unmute and speak something? Host, is it possible to unmute Archana? Because she cannot unmute herself. That is what she has messaged.
Yeah. Yeah, sir. Now I can unmute.
Yeah,
Sir, I have seen a lot of oils and lot of like a lot of oil in shampoo brands which claim that they have a lot of different oils. I think their claim is a bit wrong. Like, so I wanted to test it. So I would try. I would love to try that idea.
I think your
And that
technique,
oil.
your idea, yeah, your idea is very good. Yeah, you continue. You were saying something. I think we lost the connection. Something. Yeah, but Archana's idea is, yes, it's an excellent idea. Now, if you can note it down if you want, for extracting an oil. Okay. Now, an oil is not easily extracted. You cannot simply add some compound chemical to it and extract it. What you need to do is you need to add probably an alcohol or chloroform to this oil. Okay. After that, mix it well, sonic it, and then keep it in the deep freeze.
Yeah. Yeah, sir. The oil's name is Himani Seven Oils in One. Like I would to add up
Okay.
that.
You can certainly check that oil. Okay. Probably take up a project like this, and you can surely check if that oil does actually have all those 7 oils. You can take 7 original oils that you know are there, lay tracks for them for that oils, find out the fingerprint of that oils, the original oils, and then check your Himani 7-in-1 oil. If you actually get those bands in that, the Himani formulation, then yes, they are using. But if they are not using, then you will certainly will not see those bands there. And yes, that will be your confirmation. It's a very good idea, Archana. Thank you so much for participating. We have also got a beautiful idea from Tanisha Sirsar from SPK Savantwadi. Okay, now she says that she actually talks about using this chromatography for various things. She has written 2 3 project ideas. One is finding out impurities, okay, and purity of components, yes, toxic materials. The third idea is TLC can be used to find out various components of soil, okay, and control its fertility by identifying right amount of various minerals, salts which are required for proper growth of plants. Now that is a beautiful idea, and there is a huge scope for a project like this, especially from where you are. Okay, there is a lot of farming also which does occur, and if you can actually take soil samples, you can analyze those soil samples. I think this is a very very big project that you are looking at. Tanisha, if you are around, can you unmute yourself? Tanisha Sirsat, it's SPKM. Host, can you unmute Tanisha, please? She is in the meeting.
Yes, sir.
Yes, Tanisha, would you like to speak something about your idea? Your idea is very good.
Yes, so we can use.
Please continue. Tanisha, I think you have muted yourself here. Yeah.
Yes, so we can use TLC for finding out the right amount of minerals and salts.
Now, there is a slight trick here that using TLC directly plainly for minerals and salts might pose a slight amount of problem for you. Okay, but yes, you can overcome this problem by doing some pre and post additions, okay, to the plate, which can be done. And yes, you can, you should, I think you can easily work this idea out, and you can get in touch with us if you want any assistance for the same also. And I think this will be a very good project.
Okay, thank you, sir.
Thank you so much for participating. We also have Nirmiti Thakur from KC College. Now, her idea, Nirmiti, would you want to unmute yourself, please? She says that feedback mechanism of plants can be actually assayed or evaluated using chromatography. Nirmiti, would you like to shed some light on your idea? Host, kindly help Nirmiti unmute, please. I don't think she's able to unmute. She's in the meeting. Nirmiti, you can put on chat also your idea because it's a very interesting idea. What do you mean by feedback? That is what I think we all would like to hear. What is your idea about feedback, or what do you wish to know about feedback mechanisms, and how do you wish to use chromatography for analyzing feedback? It's a very interesting idea and quite new, actually quite new. We do have Kanishta Rambal also from KC College, which she also has a very good idea. Uh, So Nirmiti says she won't be able to unmute. That's unfortunate. You can put your idea on chat also. I think people would want to just read your idea. Kanishta says the use of many of them actually have proposed the use of chromatography in cosmetology again, which is yes, it's a good idea again. Nisha Rangres from Momin College. Now she has got another brilliant idea for the use of chromatography. Okay, in what is masala analysis, which is again a brilliant idea, Nisha. Would you like to add something on it? If you want, you can unmute or you can speak or just comment on the chat also.
Yes, sir.
Yes, Nisha. Thank you for joining us. Can you just let us know what your idea is?
So my sisters, उनकी शादी हो गई है. वो बोलते हैं कि जो मसाला हम लोग यूज़ करते हैं और जो वो यूज़ करती है वो बहुत डिफरेंट होता है. वो उनका बहुत अच्छा है. तो आई वांट टू चेक दैट क्या डिफरेंस है उसके और मेरे मसाले में.
Now it is actually, I mean, every research has all these kind of premises only. Thank you for joining us. And it's actually a very good concept where you can masalas can be extracted, and you can actually put them on plates. You can take 5, 7, 10 masalas, or regular garam masala or whatever you have, whatever you use, okay, from the local market, extract all of them, compare all of them with each other. Say 10 brands of garam masala or something which your family has made at your place or something like that. Compare them. I'm quite sure you will be able to find out if there is something really different in your sister's product that she uses and the product that you use. Again, a very good idea. Thank you so much for joining. Now, I would like Pratik Chobe to join also on the session, because his idea is again something that I would want himself to explain. It's a very interesting idea wherein he wants to use chromatography, okay, to know what stuff is getting digested, what cannot be digested, which is again a very interesting idea. Pratik, are you there on the session?
Yes, sir.
Yes, Pratik. Would you like to share your idea?
So my basically idea was that many dogs or hares they eat their own feces. So there is some vital nutrients that they don't able to digest. So using chromatography or TLC, I want to know which vital nutrients they were not able to digest. So we can make some foods, or rather some company we can show some ideas that this particle they cannot digest, so making it less soluble or less digestible, so we can make a more efficient technique to make it cheap food, or say it like that ki, they can be easily digestible to all the animals like that.
Oh, that is a brilliant idea, Pratik. And yes, I'm not sure if any this kind of study is done. With what I'm quite sure that all of the organizing team will be agreeing with it. What I'm very happy about is there are sincerely some ideas which are very unique. Now, this idea I have not heard. Okay, I'm not sure. I'm not sure about other teachers. They might have. They are more experienced, but this is a very good idea. And yes, you can probably check out if there are some nutrients and something that is. And yes, chromatography can be used for this purpose also. A couple more ideas that I would like to share with you. One is Nandini Jha from KC College. Now she proposes the use of chromatography to actually analyze evolution, and then also for pain relief creams, okay, which she wants to compare out. Nandini, can you please unmute yourself if possible? I don't think she is able to unmute. That's okay. It's a very beautiful idea. There are certain studies wherein markers and markers, biochemical markers and
Hello,
phytoconstituents are used. Yes, Nandini,
sir.
we can hear you.
Yes, sir. So the first idea to analyze evolution was, I thought there are certain living fossils there on the planet, so we can, derive samples from them, prepare samples, and other plants we can take samples from them and actually see the extent of evolution or of what changes have occurred over time. So that was the first idea. And for second idea, I've seen that we have pain relief creams like Volini, and there are different brands of them, and each one claims to have the same components. So we can actually check if those components are there, and second, the amount of those components, if they are in the right quantity, and on basis of that we can check if which one is the most effective one. Those were
Brilliant.
that's what. Yes, ma'am. Yes, sir.
Brilliant. That's a very good idea. Now, for the label claim, your second idea, you will actually find some studies online which are do happen in this area. But yes, you can check many things. Now, the first idea is very interesting. I think that is something it holds a lot of water. It has a lot of scope, and I'm quite sure if you can just develop it a bit more, it can become a very good project. Thank you so much. Thank you so much for joining. Thank you so much for the idea also. And the final idea that I was to discuss for the day for our brainstorm part is from Anand Jha. He's joining us from BNN College, Bhiwandi. Okay, wherein he proposes the use of artificial food color analysis by chromatography. Do we have Anand here today? Yeah, Anand Jha, BNN
So
College,
we
Bhiwandi. I don't think he has a got chance to connect, but yes, that is also a promising idea. Okay, in fact, there are many studies which are being done currently also for uh, for understanding what is artificial color, how much is used, how much is good, how much is bad, and so on and so forth. So thank you so much all of you for joining us with the brainstorming session. There now, to conclude this part, what I would like to add to it is this day three, though the actual day three of the workshop is today, the workshop does not officially end today. Okay. To add to this, we all please do not leave the WhatsApp groups or do check your email addresses also. We will be providing you with some amount of data. We will be providing you with some amount of data, okay, in the form of a document also. And you're all requested to do a simple thing. Within the next 2 days, you will be sent with a document. Hello, hello.
yes,
Yeah,
sir, you're audible.
within the next 2 days, you will be sent with a document. Okay, another feedback form, which is called as the post-event feedback form. You will be learning three techniques that you have learned. You have learned to use a small chalk for chromatography. You have learned to make a plate at home, okay, using simple corn flour. and then do chromatography of a simple corn floor made plate. And you will also be learning paper chromatography today. So in the next 2 to 3 days, okay, you are all you should do these techniques at home, practice these techniques at home, devise up your own project, use simple samples. It can be ink, it can be food color. There will be some ideas which will be floated in your WhatsApp groups also, with a document. Develop them, and on the third day from today, okay, we will be sharing another feedback form. You will be filling that feedback form and then posting a photograph, a single photograph of the activity that you all do. Okay, whichever you do, there is no restriction on what you do with chromatography. As I yesterday also mentioned, sky is the limit. Okay, you will be submitting that feedback form, and that is where your workshop part actually completes. Okay, so more about this later as the session ends. Once again, thank you so much for joining up in the brainstorming session. Over to you, host.
Thank you, sir. I think that all of the ideas were very great and creative. I would now like to call Mr. Shivam Sharma from the Department of Chemistry to introduce our speaker for today.
Thank you, Ria. So it's my honor to introduce our today's resource person, Dr. Charu Chaturvedi. Dr. Chaturvedi completed her BSc in 1994 as a gold medalist in chemistry. She completed her MSc in 1996 with a gold medal in organic chemistry. She earned her PhD in 2002 in phytochemical study of some medicinal plants of Labiaceae family growing around Morabad region. She has worked as a research scientist in analytical department in Ranbaxy Laboratories Limited in Gurgaon. Dr. Chaturvedi has also worked as a senior research scientist in quality control department in Cipla Limited, Mumbai. She has been a full-time lecturer in chemistry department in Ratnam College, Bhandup, Mumbai. Dr. Chaturvedi also worked as a lecturer in senior college under FIP in KC College. Currently, she is an assistant professor of chemistry department in Kishan Chelaram College, Churchgate, where she is a member of board of studies for chemistry and yoga science. And last but not least, presented a talk show on Mumbai radio on the adverse effect of pollution on the environment. I hereby welcome our today's resource person, Dr. Charu Chaturvedi. Welcome, ma'am.
Thank you, Shivam, for the kind words and the very elaborated my introductions. So, good evening, everyone. It's time to share my screen. Actually, basically, Shivam, will you please stop sharing your screen? Sonia? Why it's not coming? Are you able to see my screen?
Yes, ma'am, your screen was visible, but the email chat was visible.
Okay, just a minute, just a minute.
Yes, ma'am.
I think now you can see my screen, everyone.
Yes, ma'am.
Yeah. So from the last 2 days, and today is the concluding day of chromatography, I think you all should be aware what is chromatography all about. Can anyone tell me what is chromatography? Anyone please unmute yourself and you can write in the chat box what is chromatography all about. Anyone? Okay. So basically, chromatography is a laboratory technique for the separation of a mixture. The mixture which is dissolved in a fluid called the mobile phase, which carries it through a system on which it is fixed a material called the stationary phase. So in a simple way, it's a very different. In each and every chromatography, there will be one stationary phase and there will be one mobile phase. And how we are selecting the stationary phase and how we are selecting the mobile phase, that is very, very important in any research, because that is not we are finding in any of the literature. Sometimes the research what we are doing, we will get the literature, but sometimes whenever we are making a new compound, we will not find out the exact literature. So we have to create our own chromatography column and our own chromatography plate, or sometimes the mobile phase also. But nowadays, actually, the objective of the chromatography is to separate the various substances that make a mixture. The application of range from a simple verification of the purity of a given compound to the quantitative determination of a components of a mixture. So the beauty of the chromatography is, which I'm liking most, this is my perspective, maybe I'm wrong, yours is different else. The beauty of the chromatography is we required a very, very less mixture. If we are having only 1 gram of a mixture, we can do the chromatography. We can, depending upon the nature of what type of a mixture we are using, according to that we will select whether we will do HPLC, GC or HPTLC, TLC or paper chromatography. The second beauty of the chromatography is the entire procedure is very simple and safe. So there is no hazardous chemicals which we are using in this. I know we are using volatile chemicals, but that we can avoid by using a mask. And the third, which is the most beauty of this particular chromatography, any kind of a chromatography, that is the experiment can be conducted in a very clean way without any mess. So when you are doing the gravimetric analysis, when you are doing the volumetric analysis, in such you will get some acid vapors, maybe you will get some other things which are not good for your health and for your hair or for your skin, and sometimes something will fall off and the entire workplace will become messy. So these three things related with the chromatography are very important. If we are having only 1 milligram of the substance, still we can do the chromatography and we can find out, find out which impurities which are present in the given mixture. Sometimes which we are not able to get when we are doing the assay of any of the pharmaceutical in companies or in any companies. Maybe we are getting 90% pure compound, the 2% is impurity. In that 2% we know okay, this is the major part as an impurity, but sometimes in the impurity lab when the sample will go, what will happen? You will find out 0.001% some hazardous chemical which is present, and that only we are able to find out with the help of chromatography, nothing else. We cannot do titrameter method, we cannot do any gravimetric analysis, we cannot do any other type of a separation method. Only the possibility by which we can find out the traces of elements and traces technology, that is chromatography. So this is the chromatography all about, but my main topic is paper chromatography. Let's move to the paper chromatography. But before starting related with paper chromatography, let me tell you the background of paper chromatography. It is a very simple form of chromatography method, which has now become an extremely valuable analytical tool to the organic chemist as well as for the biochemist. Paper chromatography was first introduced in 1961, and the name is capillary analysis. We were not saying this is a paper chromatography. Under the capillary analysis, the paper chromatography, or we can say this technique is introduced. Later on in 1963, this is separated from, because this technique is became very popular, and we have separated as a different type of a chromatography, and which is known as paper chromatography. Now in paper chromatography, what we are using a special type of a filter paper, which is replaced with the help of silica gel, and the solvent which is miscible with water, like butanol. If we are using butanol, that is soluble, or we can say it is miscible in water. And if we are using any other which is miscible with water, we can use as a paper chromatography. Sometimes we are not using water also, depending upon the nature of the substrate which we are going to separate. Now, the paper chromatography is defined as the technique in which the analysis of an unknown substance is carried out mainly by the flow of solvent on a specially designed filter paper. Now, what is a specially designed filter paper? It is actually made up of 95% alpha cellulose, and which is called as Watsman filter paper. Now, this Watsman filter paper, what we are using for chromatography, it is Watsman paper, filter paper number 1, 2, 3, and 4. In most of the paper chromatography, we are using paper 1, but in 20% we are using paper 4 also. Now, what is the difference in between the Watsman filter paper and the ordinary filter paper? Why we cannot use the ordinary filter paper? To understand this, I will give you a very simple example. There are two type of slides. I'm not talking about that slide which is we are using we used yesterday, or we are using in a this dissection box, the slide which is there in a playground, right? So slide A, which is having a uniform smooth surface, kids can easily slide from one place to other. It is a very even, that kid will come from up to down in a very easy way. Now the slide B, it is completely a roller coaster ride. What will happen in such case? First, the kid will go up. That time again it will come down. The speed will vary. And if similar thing is happening in case of filter paper, first of all, the most important is the size. The size of the filter paper is very big, by which maybe the mixture can just go in the mobile phase. So we cannot use filter paper. And second, which is also a very important thing, it is not uniform. So when we are applying a mixture with the help of any applicator, whether it is a capillary, whether it is a syringe or micropipette, the mixture should apply. After applying, it should move, and when it will move, and whenever we are doing ascending or radial type of a paper chromatography, the surface of the paper should be very even one. It should not be uneven. So that is the rule by which we are using the Watsman filter paper most of the time, paper 1. And this 1, 2, 3, 4 is a porous size. And Watsman filter paper 41 and 42 we are using for gravimetric analysis. But for chromatography, most of the time we are using chromatography paper number 1. Now, what are the different mobile phase which we are using in a paper chromatography? It can be isopropanol with ammonia and water. The percentage may vary. It can be normal butanol, acetic acid and water also. It can be water phenol system also. It can be formamide. It can be chloroform. It can be benzene in any ratio. And we can mix dimethyl formamide with cyclohexane also. So when the non-polar substrate is there, that time we are using cyclohexane. So depending upon the nature of that, we are deciding which type of a mobile phase we will use. The choice of the solvents depend entirely on the nature of the substance to be separated. There are two different ways to solve this problem. One is you just find out in the literature, and the second one, which we are most of the time we are following, that is by trial and error method. So because sometimes if we are doing a real research, we will not find out which mobile phase we have to use for the separation of the compound which you are making. So we just go through with the literature what type of a similar compounds and they are using as a mobile phase. In that we just little bit do the changes, 10%, 20%, we just hit and trial we are doing that, otherwise that is not possible. So this is the brief introduction. So in any of the chromatography there will be one stationary phase, other one will be the mobile phase. Now today the session is hands-on. I think you all are excited for the hands-on session. So let's start doing the hands-on training. I think you all are ready with your substances, the filter paper, the glass and water, whatever I told you. Are you ready everyone? Just write in a chat box. Okay. So let me just arrange all the things in a proper way and then I can do the chromatography. So this is the paper which we are going to use. This is called as Wattman filter paper. Now, how to hold this paper? Always hold the paper in this way. Why I am saying this? Because if the impurity which is present in your fingertips, maybe it will spoil the filter paper, Wattman filter paper. Put this filter paper and just use a pencil. We never use a pen because pen is having a water soluble ink and that will also go with the help of a mobile phase, whatever you are using. So we always use the pencil whenever we are using doing the any type of a chromatography, whether it is a TLC or whether it is a paper chromatography. With the help of a scale, just 3 inch above, just draw a one line. Are you able to see everyone, Siddharth? Is it visible properly?
Yes, ma'am, it is. If you could focus the camera more down, the
Down. Okay, that's why I'm
yes,
asking you. Now it's okay?
yes, ma'am. Now it's perfect. Thank
Perfectly.
you.
Okay. Now just draw one line and to this, actually my favorite color is black. Why it is so? You will see now why it is black color. Can you tell me this is a mixture? Because this is a black color. We are able to find out how many dyes are used to make this watercolor, that is black sketch pen. And I just put a very small dot. Don't put very concentration should be very less. It should be a very small dot. Otherwise, it is difficult to separate out. Now we will take one glass. I have cut this according to the size of a glass. So there is no need to put some clip or thread or stapler, or otherwise if you are not able to do this, you can use this clip also with this. But my this one can go very easily in this glass. So I will just cut the side edges. Or you can use thread also because you all are using the filter papers, right? So what you can do, just take one pencil or pen and take this in this way and staple it, or just paste some glue or something and you can just pour this inside the glass. Choice is yours, whatever you want to follow, you can do it. Now I will add some water. Now this water should be less because the point which this should not go in mobile phase. Can you see this? and it should be little bit down. So first you just draw a baseline, and in the baseline you just put a small point of the sketch pen with black. You should use the black sketch pen, and now you can insert, just see whether, no, it is having little bit more water. So what I will do, I will just remove little bit, and then I will pour this, put this inside. One more activity we will do, in which this will separate. You can also start doing yourself. Now in the next, yeah, which where we will just put a mark. There is one surface in a Watchman paper which is smooth, the other one is rough. So we will just put the mark on a smooth surface. Can you see? It is already started. Siddharth, is it visible?
Yes, ma'am, it is quite visible.
Okay. Now just see the other one also, in which I will just use so many sketch pennings, and then we will see the RF value, whether it is same or different. So I'm using again black. I will write black here. I will use brown, and I will use orange. Right? So where is black? The brown. And the orange one. This is red, this is orange. We always run the plate minimum 75%. That is a standard procedure. Now why I'm telling you, supposedly if I will take this plate out, or Whatman filter paper out from the chamber, actually it is a glass, it's not a chamber. So what will happen? Can you see the separation? But in that, the separation is not completed. The blue color is not completely separated with the red or yellow color, and red is not separated completely with the yellow color. So we have to run, sometimes we have to decide the length of the TLC plate should be more. So depending upon the nature of a compound, we decide whether we will use a 6-inch, 12-inch, 12 or more than that one, and we'll change the procedure, because the silica plates already which is available in the market, it is of a 6-inch plates, and most of the time we are using 4 and 5-inch plates, not more than that, because then it will become very difficult to use a very if we are using a 12-inch or 8-inch, then we have to use a very big chamber for the separation. So that we are not doing. Now you can see when it is just moving up, you can see the separation clearly. Can you see? Can you see this?
Yes, ma'am.
Yeah. So what next step will be there? We will just put a mark on the solvent front, how much solvent front is run. So we will use the pencil again. Just wait and watch. Meanwhile, you can just switch on your videos. I can see yours also, what you are doing. Are you using filter papers? We can use filter papers also, but with the help of filter paper, we can see the separation, but we cannot calculate the RF value because we will not get the exact RF value in this, but we can see the separation. We can see the separation very easily in this filter paper also. Just I'm removing this and putting this one again in this, in which I just put used 3 colors, orange, brown and black. Meanwhile, what we can do, we can calculate the RF value of this one. Just see, let it dry first. Can you see this? Now, first of all, what we will do, we will just mark this till what the solvent, or we can say the mobile phase is there, and we just measure this length. And how we will do this? With the help of a scale. And this is the baseline. With the baseline, we will just find out the total run time or run length, that is 7.2 centimeter. So this is the distance traveled by the solvent. Now what we will do? What we can see, I can see one blue color here. One, actually it is yellow, but the separation is not completed. That is why it is showing little bit brown in the color, because it is a mixture of red and yellow. And one more color here. When we are not getting a proper separation, in that case, what we are doing, we are just selecting the middle part of this. And now we just measure the length traveled by the substance or that particular dye. So the red color is 4.4. The yellow color, which is coming brown here, that is 5.6. And the blue color is showing 6.8. Now, can you calculate the RF value of all these color? 4.4 divided by 7.2, distance traveled by the red dye, and total distance traveled by the solvent system. Now, distance traveled by the yellow color, which is 5.5 divided by 7.2. The 7.2 will remain constant in each and every one, and 6.8, that is the blue color, which is there. Now, what I want to show you in the other one, that is also very important. Can you see this? Can you see this, everyone? Just see in this, a brown color especially. The blue color, is having a same RF. Here there is no blue color. And the yellow color is also having a same RF. And here it is actually red color. Now, can you tell me, if we are doing this quantitatively, if we want, I'm not saying that I have done this is quantitatively, but just by looking this, we can get an idea in which the blue color is added more, in which the blue color added is less. Can you see this? In this, the intensity of the blue color is very high. It means if I'm just talking about the substance of a mixture which is having a different type of a substance, then we can find out in this particular compound is more. Here it is very less, but the yellow is more. And here the red is more and yellow is less. So that is why we are saying this is orange color. In orange, what we have done, we have a mixture of red and yellow. In the brown, what we are having very little blue, more of yellow and more of, that is red color dye. But in case of black, we have very high concentration of blue, very less concentration of yellow, and very high concentration of red. Is this much is clear? Yes, now we can do, this is what we have done in water. Now supposedly if we are changing the mobile phase, and how we can do that part, that is also very important one. We'll see later on, it will dry up after that. Again I am taking more glasses and I will add water in this. If we will increase the polarity of water, so what changes will be there? So for to increase the polarity of water, because it is a water soluble ink which is present in the sketch pen, we can add salt. And if we are adding salt, this is 1/4 tablespoon which I am adding in glass 2, and 2 tablespoon in 1/4 tablespoon 2 in third. So, and we will mix with the help of a any, you can use the straw, you can use any spoon, just mix it. Why we are doing this? Because when we just want to see whether we are getting the better results in the different solvents, mobile phase, or it's the same, is there any change will be there, or there will be no change. We'll see. So what we will do in this, again we will just put a mark, let it dissolve. Meanwhile, what we can do, we can take three strips. Again, we will just mark them. Here's the pencil. And we can just put two only. We can use orange, very small, and we can use purple also, right? Okay. Now I'm just putting this in a glass containing only water. The second is going in which less amount of salt is there. And the third one is going, so if it will dip, you just put this with the help of a clip. This is going in the where the salt amount is more. Can you see the separation in all three? This is clear cut 100% water. In this, less amount of salt, and in this, more amount of salt we have added. Because we have added salt to the water, what will happen? the flow of the liquid will become slow. So in the water, see, it's going very fast. In this, it is also going fast, but if you compare these two, here the separation is slow because the viscosity of the solvent is more. So sometimes when we are using a more viscous solvents, which is most of the cases we are not using for the paper chromatography, in that time the duration will be more. So most of the time in paper chromatography we are avoiding the viscous solvents. This is the reason, because the run time will become too much and we cannot wait for the results. So when you will add more and more salt, the solution will become viscous in nature. Now can you tell me where the separation is the best one? This is the first one in water, this is the second one, and this is the third one. At least you can see the band. In this, the band is not coming properly and we are not able to get the proper spots. But in the first and second and third one, we can see the separation. There is no as such spreading of the substrate or dyes which is present in the ink. So basically, acha, okay, you cannot see the third glass properly. Okay, now you can see.
Yes, ma'am. Now it's visible.
Can you see that? Now you decide which one is better, where you can see the proper separation. In the saline water, when the saline water is more concentrated, and in water. I can remove this. Just see this one. Is this clear? No. Okay. Just wait a minute.
Ma'am,
Yeah.
I'm so sorry to interrupt, but we have a query in the chat box. It
Yeah.
says that we were told to prepare A4 size drawing paper rather than a Wattman paper. So the ink is not separating and the paper is also melting away.
Yeah, I know you are using this filter paper, A4 size paper. With the help of A4 size paper, we are just doing the drawing part. We are not going to use as a chromatography paper. You can use this filter paper. Okay, you want how to do this? I will tell you that. Actually, with the help of this, we will do the fun, and this is the theory part which I want to share with you. So if you want to do the chromatography in this also, use the this tissues, and I know it will melt. It will melt. So what you can do, but you can do the separation in this also. That's not a problem. Just put a one dot over here and one more over here, and I can use black again and just put this in this way, in the water only, and just separate that, and it will melt. Definitely it will melt. This is the substitution which we can do at home, but this is not the right way of doing that. Are you getting my point? So this is the tissue papers which you have. You can use this one. Now can you see this? In this also it is, see, you can see all the spots which are coming. Don't wait too much because paper will melt. Definitely it will go in the solvent. So in the black color, you can see all the colors, but the separation is not good. And here also you can see actually this activity on the tissue paper we are doing just to find out how many mixtures, how many means present different dyes which are present in the black ink. So with this we can find out how many are there. 3 are there in black. In orange 2 dyes are there. So this is a very simple process which you can do at home, but this will not give the exact value of RF. And that is why we cannot use filter paper when we want to calculate the RF value. If we just want to find how many components are present in a given mixture, then we can use. But we cannot use to calculate the RF value. For that, we required a proper systematic, and we have to follow all the procedures. Any doubt, beta, related with this? No, these are the different papers in which we have changed the mobile phase, in which one was water. This is water separation, completely a water separation. And here we can say less saline. And here, sorry, this is less saline and this is more saline. So when you will increase the viscosity, sometimes it will take more time, but the separation is better. So depending upon the nature of the solvent, we can get different type of a separation and we can get different RF value also. Now you can see in this, especially the purple color, you can see the blue color which is separated out here, and this is the red actually which is not separated here. Again in this also you can see a tinge of blue. Are you able to see? Very tinge of blue in this also. Siddharth, please. Ria, any volunteer, please tell me, are you able to see the blue color in this? The upper part?
Yes, ma'am.
Yes,
Just
ma'am.
slight.
So this is all about the sketch pen in which the ink is water soluble. Now we'll do and we will find out with the help of permanent ink whether the permanent marker are having which type of a ink, which is water soluble or it is soluble in 50% alcohol or water or in alcohol only. So what we can do, I will use the same. I will add little bit of water in this, and this I will not use. So let me throw this. And let me clean this. This is water, 100% water. Now what I will do, I will add little bit of water and half of alcohol. I'm using sanitizer which is available at home nowadays because of pandemic. Because alcohol is there, so we have to cover this. And in this, the third one, we will use only alcohol. Again, we will cover this with the help of. Now, again, I will use a paper. You can use, acha, you want to use this one? Yeah, I'm not using now Wattsman filter paper. I'm using an ordinary filter paper like what you are having. And here we will do the separation. I'm using the brown color. and I will put this in water. And the remaining one, again I'm using filter paper. In this I will just put one brown, and I will put this in a system in which 50% alcohol and the remaining is water. And in the third one, in which only alcohol is there. Can you see all the three glasses?
Yes, ma'am, they are visible.
So in water, only a very small component is moving with the mobile phase, but you can see in 50% alcohol and water system, the whole entire mixture is moving up. And what about the alcohol part? It means in the permanent ink, it is a mixture of water soluble and water insoluble component, and that is why the mobile phase which we are using in this, it is 50% alcohol and water. Only alcohol is not good for the permanent ink marker. If we are using, then we can get better results. So because I have done this on an ordinary paper, we are not getting a very good results. Acha, okay, now you are able to see that. Are you able to see
Yes,
that?
ma'am. Yes, ma'am.
So this
It's
is all
visible.
about the chromatography, how we are calculating the RF value, how we are deciding the mobile phase, how we can do the modification in the mobile phase. Now, I think you all should know the fun what we can do with the help of chromatography. So actually, why fun is learning works better than dull learning. Let's find out more what we can do with the help of chromatography. So I am very excited. I think you all are also very excited which we can do with the help of chromatography. So the first thing what we can do, we can make chromatography flowers. Is it amazing? So we are going to use this. I will show you what we have done today. Workshop, each and everything. First of all, what I required, you can use your papers, filter papers, but I am using the kitchen paper towels. So first of all, I will take one square and I will make a circle of this one. First fold and second fold. First make a square and then cut it in a circle. You can take a help of any vessel which is in a round shape, but I am able to I'm very much comfortable using the scissors, and I can make a circle which I require to make a flower. Please do everyone this activity. I want to see your creativity also. And you can draw any patterns. Don't follow what I am doing. So this is the flowers. Now I just required 4 glasses. And in this we will add water. How much water? 3/4. And now we will do radial chromatography. What is radial chromatography? With the help of a wick, the mobile phase will move and we will get a different patterns, and we will see all the amazing patterns. First of all, I will just see whether, yeah, perfect. So the next step, I will start making a drawing on this filter paper, not filter paper, tissue papers, right? So then you will say, ma'am, you are saying filter paper. We have a tissue paper, so we are using tissue papers only. It has gone. Four should be there. Okay, we'll start drawing the lines now. I want very nice shapes. The first thing what I'm using orange color. I'm making hearts. You can make whatever you want. And after making hearts with orange color, I will use little bit of pink color. Can you see what I am doing? Are you able to see this?
Ma'am, can you please pan the camera downward? Yes, ma'am.
Just a minute. I will show you.
Yes, ma'am. Thank you, ma'am.
And I will use some blue color, which is, we are saying frosy color. I don't know what you are saying, but we are saying this is a frosy color. And I will make a one circle with this. Right? Now what I do, I just put a hole here. I will make a hole here, and then I will make a pointed. I will use some tissue papers. This is not normal tissue paper. Just cut it in a strip and make a wick and just put it here in this way. The remaining part will go in water, and now just see the amazing patterns which will come out. You can see how it will. Just, it has gone. No, I will take one. It should be little bit out, and then you put in water. Then it will not go. It's okay. The other one which I'm using, which color you want? I'm using now yellow, right? So I will make some lines. I will just make some zigzag with the help of pink color. Whatever color you want to use, you can use, and just share with me also, because I know you are better than me in creativity. I'm not very good. As per your choice, you can make any pattern. Can you see? Can you see this?
Yes, ma'am. Yes, ma'am.
It's really beautiful patterns which are coming out. Again, we will make one more with the help of this one. And we'll add this. The other one which I'm using, I will use the green color or purple color. Now I will use some red color also. Make some patterns, whatever you like. I will use some yellow also. And now I will use some basic orange.
Ma'am, I'm so sorry to interrupt, but I think the first one will overrun. If you could please.
Yeah, no, it will not go, because
yes.
Nothing will happen with this.
Okay,
Don't worry about that.
It looks beautiful.
It looks beautiful and we will make flowers. So let it dry and we are making so many now. So again, I will just do a hole in this and we'll do some paper, put some paper. And this is called as radial chromatography. It is a type of paper chromatography. So this is, I think this is also done. Now can I see anyone who is doing also this? Just show your patterns also which you are getting. This I did in the morning just for you only. So I have made all these patterns with the help of paper chromatography by using only filter papers. This is the one, this is the other one. You can use anything. You can just make any pattern and we can make so many different patterns with the help of paper chromatography and we can make flowers. So how we can make flowers? First of all, we'll cut the side edges of this one. जैसे मैंने इसमें किया है, you can see in this, and this is dry also. So I can use this one, fold this in this way. Are you able to see this? And put some, use some tape or whatever is available at your home. I'm using Abro tape. And after using the Abro tape, we'll close this in a proper way. And where is the, yeah. We'll attach one. This is what? Can you guess?
Straw.
Yes, so we can use a straw if you have some sticks or at home or you are getting some wire at your home, you can use anything. So I'm using a straw. So you just put the straw and just close this, tightly close this and make a flower. Can you see this? Are you able to see this? Nice flowers which we can make with the help of paper
Yes, ma'am.
chromatography. Now this is also coming. You can see this pattern also. This is also very different, but still I will wait because yellow will also go in the different direction. Now when we are getting this one, what you do first, just make one bigger and other one as smaller. Don't run too much. And now cut the sides of this paper. I'm just removing this also. It's done. Let it be. Now this one also we will cut. And again we will fold. If you want to cut this in this way as a leaf way, that you can also do. Fold this again and cut this. Now you can make this one a different flower. This is also looking amazing, right? So you can do so many things with the help of paper chromatography. I'm just showing you the two type of flowers or This is the other one which I did now only for you. This is the, now you can see the patterns which are coming. So paper chromatography is a fun actually. With the help of paper chromatography, we can make so many cards also, we can make flowers also, we can make butterfly also. Just see here in the next slide. If the kids at home, you can give them and you can just make the beautiful colored butterflies, and you can make so many patterns also. That I am showing how to make different patterns. That is also very nice activity which we can do with the help of a paper. Let me remove everything. Now, the next is what we can do with the help of this one. This is our tissue paper, ordinary tissue paper. So what I will do, I will make, this is the flower for you only. I'm just putting it here. Now what I want, you just put your A4 sheet drawing and then after that you put this filter paper. So I'm going to use this one. And after that, what I will do, I will just put this paper on the A4 size sheet. Now what I do, I will just make different patterns. How I will make different patterns, you see. I am making zigzag, the big zigzag. With one color first, then other color. Then what I can do, I am making hearts in between with the orange color. I'm drawing lines. I'm using frozy color, that is blue color. Again, I'm just putting a zigzag. Are you thinking how I will do the means chromatography in this? Radial chromatography, or how means I will use a chamber? No, I'm not going to do that. I will do something different with this. Now tell me which color I can use in this. Yellow also. Fill this with, make some patterns. Right? Now, what I'm going to do, I will take a one straw again. And with the help of a straw, what I will do, I will put some water. Kahan kahan middle mein aise. And I will wait. What pattern is coming? You can use dropper also. It will take time actually to dissolve and to just spread out in the entire sheet. But because I did it for you, because we have less time, we have to complete this activity. This I did what I am doing now. You can use this paper to make flowers, to make cards, or you can make so many patterns, just like whatever you want. Just do, think in a different way, imagine yourself and do the creativity with paper chromatography. And this is normal tissue paper, which we are using at home, but the better one. This one, this is very thin, and this is the little bit thicker filter paper or the tissue paper which we have used. Is this amazing?
Yes, ma'am. Indeed, it is amazing.
So
I think we all
I'm not
loved it.
doing this. I just want to tell you one more thing which we can do with the help of chromatography only. This is the silk fabric and we can make a scarf. Again, it is all because of the chromatography. What we can do, we are using for to dye this. We are using, actually this I did in the morning to show you. Now I am doing in the other side of this. We can use the permanent markers, and how we will do again in this, we will draw some patterns. Whatever patterns you want, you can just do that. Now, because I have only two colors in permanent marker, but in market all the colors are available. So you can buy according to yourself, whatever the colors you like. I'm just doing randomly because I think it's 6 o'clock. We have to close this. Now what I will do, I will spray some sanitizer which is there at home and see what the pattern we are going to get. And this we can make very beautiful sorry. Can you see that?
Ma'am, can you pan the camera down?
Yeah, beta, I'm doing that because see, after spraying the this, my you can see the different patterns which can come, and you can see you can make the scarf at home. This I did in the morning. You can see the pattern which is coming after that. Can you see that? And in the
Yes,
similar,
ma'am.
now you can see here also. It will take time. I'm not saying it will not take time. It will take time and you will get very different patterns. Actually, I'm not doing, my laptop is, can you see that? Can you see that now?
Yes, ma'am.
I
Clearly.
cannot do this activity near to my laptop.
Yeah.
So very beautiful pattern which you will get, and the best part, once it will dry, the color will never go. So you can wash and you can wear also as a, you can make the scarf, you can do the picot, you can do the, you can put some laces and whatever you want, you can do that. So this is all about the fun of the chromatography. We have learned the first paper chromatography, how we are calculating the RF value, how we are deciding the mobile phase, which will be better one and which will be not good for the separation, and more viscous most of the time we are avoiding, but in some particular type of a mixture, the viscous are better one, because if the bulky molecules are there, if the molecules which we know is very high molecular masses, then in that case actually we are using the viscous solvents to separate them, because if we will not run for a longer duration, they will not go and we will not get the separation. This is the ultimate. When we are doing the research in research lab, we will find out the different type of mixtures which is present, and sometimes we cannot avoid the viscous and we are using cyclohexane. Whenever you will use 100% cyclohexane, the run time will become 2 and 3 hours. So this is all about the paper chromatography. Now what we did actually, just see, we made this one, these patterns. We made flowers today. And what we did, we made this paper also, which we can use for the craft or whatever you want. And that's all. This also I did in the morning. for you only. This is also paper chromatography. This pattern also. So this is all about. Now, thank you everyone. And as a patient listener, because I know online it is very difficult to sit for a longer duration. Thanks everyone.
Thank you so much, ma'am, for this interactive and insightful session. Now the chat box is open for any questions. If you all have, please put them in the chat box. I would like to request Mr. Siddharth Nakwa and Mr. Anurag to begin the Q&A session.
Thank you, Ria. Ma'am, we are waiting for participants. The chat box is now open for questions. You may type in your questions, which will be delivered to the resource person.
Yeah, we can use sketch pens. We can use normal ink also. You can use black and blue ink also. They are also water soluble. But the ink should be water soluble. And if you are using water insoluble ink, then in that case, you have to use the system 50% alcohol and 50% water.
That was the question from Suchismita Ghoshal. Participants, the chat box is now open for questions. You may type in your questions in the chat box. Ma'am, we have another question from Urvi Achutan. Can we use acetone as a solvent in our chromatography setup?
Yeah, we can use acetone not as a mobile phase, but as when we want to make a paste of the mixture, like in case of pigment separation, we are using acetone as a solvent to dissolve the mixture. So we are using, but most of the time acetone we are not using as a mobile phase. In few cases, we are using 5 or 10% acetone, plant pigments especially, but mainly to make a paste or a smooth paste, we are using acetone as a solvent, but not as a mobile phase solvent.
Ma'am, we have a question from Mohammad Jahid Khan, MSc. Sometimes after drying the paper, the spots are also gone. What should we do to retain the spots?
Can you repeat the question?
Yes, ma'am. Sometimes after drying the paper, the spots or the color are also gone. So what can we do to retain the spots?
No, that you cannot do anything. We just always put the marks with the help of a pencil. We click the photographs. In that case, we cannot do anything. And in the TLC also, in TLC plates also, means after some time that spot will go because the concentration is very less. So that we cannot do. We cannot preserve the plates, or we cannot preserve the paper also.
Thank you, ma'am. Ma'am, the next question is from Sara Maniar from KC College. Ma'am, she is asking that whether we can use a substitute for the sanitizer which we just used for our silk chromatography.
You can use alcohol because sanitizer is available nowadays. So that's why I told you to use this one.
Yes, ma'am. Thank you, ma'am. Over to Anurag.
Ma'am, we have a question from Initia Jadwala. What are other solvents we can use for water insoluble sample?
What that
other
I
than
have
alcohol and acetone?
I have discussed that we can use benzene also, we can use cyclohexane also, we can use formamide also, we can use cyclobutane also, we can use normal butane also. There are so many, ethyl acetate also. There are so many solvents which we are using in paper chromatography. And all depends upon the nature of the substrate molecule. Dimethyl formamide also we are using in paper chromatography. There are so many, acetic acid, ammonia, that sometimes we are mixing 3 solvents to make a mobile phase. 80% water, 5% ammonia, the remaining is alcohol. That way also we are doing. Whenever we are putting any inorganic substance which is there, that time we are using ammonia also.
Thank you, ma'am. Ma'am, the next question is from Shubham Jadhav, who is from RJ College. Ma'am, can we use the coal for sketching? As we used various different types of colors, can we use coal instead?
I think coal is 100% carbon. If the compound is not reacting with the carbon, then we can use. I don't have any idea because the pencils are graphite pencils. That is also carbon. I think we can use coal. We can. I never tried that.
Thank you so much,
Thank,
ma'am. Over to Anurag.
thank you, ma'am. We have a question from Kumkum. Instead of filter paper or Wattman paper, what can be used other than those two?
This is a paper chromatography, so we are going to use paper only. We cannot use. This is under the category of paper chromatography. So definitely, we are going to, as a stationary phase, we are going to use a paper only. We cannot use any other thing. We
Thank you,
can
ma'am.
change the filter paper, Wattsman paper filter, paper number 1, paper 2, paper 3, and paper 4. That depends. But paper should be there.
Yes,
And few
thank you, ma'am. Yes, ma'am. Yes, ma'am, please.
No, if few components which we are not able to separate with the paper, in that case, we are going and we are just switching to the TLC. And after that, if it is not possible by TLC also, we are going for the column chromatography. Then we HPLC and then HPTLC. GC also, if the volatile components are there in any of the mixture, then in that case, we cannot do TLC, we cannot do paper chromatography, we cannot do HPTLC. Only what is remaining, that is gas chromatography. So depending upon the nature of the mixture and the substrate which which we want to separate in a different components, according to that we will decide which type of a chromatography we will use. And this is the simplest type of a chromatography which we can do with a very few things. At home also we can able to manage, you can understand. But if we want to do HPLC, first of all we require a huge money, and then we can buy the HPLC, and not only one column is required. We have to buy so many different columns in which carbon 60 is there, different type of a silica is there, what is the length of the column, and what type of a silica is there inside the column, and what are the mobile phase. And because I have used the HPLC when I was there in Renbeck C, the troubleshooting is too much there. Supposedly, if I have used the column, but I have not washed the column properly, because we have to wash the column and then we can store that column. And most of the time, the persons, they are in a hurry. What they will do, whatever is the mobile phase, they will run. After running the mobile phase, we have to wash the column without the sample 3-4 times with mobile phase, then with alcohol, and then with water. If it is water wala column आपका HPLC में अगर है तो that at least 10 उसका जो हमें we have to give the 10 times प्यूरिफिकेशन के लिए हमें इंजेक्शन इंसर्ट करना पड़ता है, प्रोग्रामिंग शेड्यूल करना पड़ता है कि वॉशिंग इज मस्ट after doing the HPLC, and that is not possible at home. So the simplest technique which we can use in the normal laboratory, that is thin layer chromatography and the paper chromatography. That's it.
Ma'am, the next question is from Mohammad Jahid Khan. Ma'am, he's asking what's the difference between Wattman filter paper 1, 2, 3, 4, 41?
That is the pore size. That is the pore size.
Thank you, ma'am. Ma'am, the next
question from stop. It's already 6:05. So you
Yes,
can
ma'am.
ask if any question is there which is relevant.
Ma'am, we'll consider this last question. Anurag, you may take over.
Yes, ma'am. The question is from Nandini Jha, SYBSC. What is the counter to current chromatography? Other separation techniques.
What are the
counter to current chromatography?
Current chromatography. Actually, current we are not too much using.
Okay.
Current chromatography
Sorry,
we are
ma'am.
using.
She meant counter current chromatography.
Acha, counter current chromatography. Actually, depending upon the substrate molecule, this is not very common counter current chromatography. Sometimes when the compound is not able to separate by HPLC, which is a very common, and not by GC, then in that case we are doing the counter current chromatography, and the process of the counter current chromatography is very tedious. So most of the time we don't prefer in industrial level pe counter current chromatography.
Thank you, ma'am. That's all the questions.
Thank you so much, Siddharth and Anurag, for taking up the questions. We would now like to move on to the valedictory function, which will mark the end of the 3 days of this exciting webinar. We have learned just so much from Yogita ma'am, Mayuresh sir, and Charu ma'am, and I'm sure that each one of us will apply this technique in our future. Firstly, I would like to call Dr. Shalini Sinha, our Vice Principal, KC College, to give the valedictory address.
Am I audible? Can you hear me?
Yes, ma'am, you are.
Okay. Just a minute. I did switch on my video. Can you see?
Yes, ma'am.
Okay. Okay. So, very good evening to each one of you. And it's a great pleasure today, especially to address all of you. And I believe there are many students who are from other colleges too. So this 3-day workshop that you have done today under the aegis of the STAR status, and it is an interdisciplinary kind of a program with 2 departments hosting it, Department of Life Sciences and Department of Chemistry of KC College. First of all, they have to be applauded for this kind of a venture during these times. You know, all of us know we are not living in normal times. And then to conduct this kind of a workshop, that too a 3-day workshop, okay, in which, you know, I was so amazed to know that they used, you could do these experiments sitting at home using the products easily available to you at home. So that is what is meant by innovativeness. So thank you so much, you know, both the departments for this whole innovative idea that you had, where students learned so much sitting at home, just using the products at home, and learned about the technique of chromatography. So, you know, I mean, this is one thing that we are missing in the sciences, that practicals are not, you know, happening in the way that they were happening. And that hands-on practicals is what students were missing. And thank you so much for hosting this kind of a hands-on practical, which students could observe and do it in their own homes. So this is a really laudable venture. I really congratulate the STAR Status Coordinator of KC College, Dr. Sagarika Damle, and the Associate Professor of Department of Chemistry, Dr. Sheila Walecha, as well as all the 3 resource persons, Dr. Yogita Shinde, Dr. Charulata, and Dr. Mayuresh Joshi. Thank you so much, all of you, for having taken this venture, and not just for our own college, but having spread it to other colleges. You know, we are must be one of the very few colleges in Mumbai, okay, which has a star status as well as a star scheme. And DBT, you know, Department of Biotechnology, is very keen that we spread these privileges that we have to the colleges around us and to others also. You know, because that's what they always ask: what have you done? What kind of interdisciplinary courses? You know, how have you extended your activities to other people? And this is how, you know, one does it. So this is, you know, this is showing the path to others. And thank you so much. Especially this whole technique of chromatography is so interesting. You may not know, you know, I am now from the Department of English. I did my PhD in English, but at one point of time, I have done my graduation in chemistry. So you know, I did BSc chemistry honors. So though it seems to be so far off, but the whole technique of chromatography was so interesting, you know, that it made me look up. And I was just sharing today how when I was in college for my own chemistry practicals, we were given two compounds where we were supposed to separate out all the elements using all the different techniques. The liquid, I think liquid chromatographic techniques we had done. And today, chromatography is so important, especially when you look at the food industry, when you look at the medicine industry, how much it is applied, especially when you're looking at the purity of products and trying to show, whether a product is worth taking in or not, especially in the food industry. So thank you so much, both the departments. Thank you so much, Dr. Sagarika Damle, for always remembering me and for always calling me, and making me a part of all your venture. So I wish you all the very best. Please take it forward. And I hope to see so many more departments getting into this kind of ventures, especially I would really love to see the star status and the star scheme doing things together. Thank you.
Thank you so much, ma'am. That was beautifully put. I would now like to request Mr. Gaurav Bengi, Assistant Professor, Department of Life Sciences, to give his feedback towards this workshop.
Yes. Good evening, everyone. Am I audible properly?
Yes, sir.
Yeah,
Yes,
yes, sir,
Yes,
you
sir.
are.
Yes, yes. So this was like one of the amazing workshop I ever attended. Right from Yogita ma'am to Mayuresh sir to Charuta ma'am. They are my teachers as well, actually. They like people might be knowing only about chromatography. Like they might be knowing only the thing that chromatography is a technique which is used for separation. But many people like this workshop, I think, has helped all the people like FS as well as right till the MSc students. The basics of the chromatography might be like it became more stronger, and the concept behind each and every separation and different types of chromatography, including paper, TLC, as well as HPTLC. So all those things made much more clear. I just want to thank each and every teacher like Yogita ma'am, Mayure sir, as well as Charuta ma'am, also the whole organizing committee who took up this topic so that each and every student has more making their base much more stronger in this particular concept, this particular topic. Thank you. Yes, it was nice overall. Yeah.
Thank you so much, sir. I would
Yeah.
also like to call Suchismita, a student from FIPSC, to give her insights on this.
Am I audible?
Yes, Uchasmita, you are.
Good evening, ma'am, teachers, and all my dear volunteers. First of all, I would like to thank you all for organizing this workshop. It's because only of this workshop that we got to get out of all our books, means like the bookish knowledge, and to get to know about the outside world, the concepts which we means basically study in our syllabus, means what are the applications and the uses in the commercial and industrial level. And the plus point was that of this workshop is that we got to perform them in our own houses, means like at our own comfort level, with all the necessity being available to us at our own expenses. So thank you so much to all our teachers, the resource persons, um, Dr. Mayuresh Joshi sir, the Charulata ma'am and Yogita ma'am, and all our dear volunteers for making us learn new things. A few changes I would love to see in this workshop would be like this. There were many things about which it wasn't discussed in this workshop, like the different uses of silica gel, from where it is used and its different techniques, like aside from the pharmaceutical applications, how are they used for the diagnostic purposes in the medical field and etc. It wasn't discussed in a bit. And even like in the industrial levels, are such hazardous substances used in this way, and if used, then what are the safety norms one need to follow, and how are they disposed of after using? So I would surely like to know a bit about it. But no doubt the workshop was too fruitful to all of us. Thank you, ma'am, for giving me this opportunity to share my views on this workshop. Thank you.
Thank you, Suchismita. I would like to request any external participants, if they wish to say something, please raise your hand so we can unmute you.
uh,
anyone?
we can go ahead with Deepika ma'am's overview, and in between, if any external participant wishes to say a few words as a feedback, please write in the chat box, and we would love to hear from you. Thank you.
Thank you, ma'am. I would now like to request Ms. Deepika Jain, Assistant Professor, Department of Chemistry, to give us an overview of the workshop.
Good evening, all of you. I'm audible.
Yes, ma'am,
Yes,
you
you
are.
are.
Okay. So, good evening, all of you. I'm Deepika Jain, Assistant Professor, Department of Chemistry, KC College. So, from 5th to 7th January, an interdepartment workshop was organized jointly by Department of Life Science and Department of Chemistry, entitled "Band It Up." This workshop was organized under the aegis of DBT's Chart Status Grant. Over 200 people registered for this workshop from the different colleges. The purpose of the workshop was to learn about different chromatography techniques and their applications in the various science fields. Participants also able to do hands-on experiment at home during this pandemic time. Aim of this workshop is to improve the knowledge and understanding of chromatography techniques. So on first day, all the participants able to learn about pigment separation. Dr. Yogita Shinde discussed about the origin of chromatography and its principle. On second day, participants able to learn about the preparation of TLC plate using cornstarch and the use of HPTLC in standardization of the herbal products. Dr. Marius Joshi also discussed about the applications of HPTLC in plant research. On the last day, participants involved in the interactive brainstorming session, Dr. Charulata Chaturvedi demonstrated at-home chromatography experiment. Each and every each and every participant took part in this activity. All, all the participants performed paper chromatography at home only and made colorful flowers from this activity. The balance of the day consisted of the interactive question and answer session. At the end of the workshop organizers collected feedback from the participant on the usefulness of the 3-day presentation and how they could benefit to their future trainings. Overall, it was a great and creative workshop to enhance the knowledge and skills in basic science by KC College, HNC University, Mumbai, organized jointly by Department of Life Sciences and Department of Chemistry. Thank you, all of you.
Thank you so much, ma'am, for summing it up so beautifully. One of our external participants has raised their hand. Could you please raise your hand again?
Is there anyone who wants to express? Please raise your hand so we can unmute you, or write it in the chat box. If not, we can go ahead.
Yes, ma'am. Lastly, I would like to call Dr. Sagrika Damle, Coordinator, DBD Star Status, Head of Department of Life Sciences, to give the formal vote of thanks.
Thank you so much, ma'am. It's with great pleasure that I'm here to do this most heartwarming task for the day, that is expression of gratitude towards all the members, or I would call them as Humsafars, who walked together with us for these 3 days. First of all, let me send my warmest thank you to our principal madam, Dr. Hemlata Bagla, who is a good scientist and a great administrator by profession, but she's a teacher at heart, and she's always there for anything and everything that we plan for our students and for the students of other colleges and faculties too. So thank you very much, ma'am, for always being there, for always saying go ahead and giving us all possible help from your side. Thank you so much. I would like to take a minute more to talk about the vice principals here. We heard Dr. Tejashree Shanbag,
who inaugurated the session, and with Justin sir. But today we had Shalini Sinha ma'am, and I must say this, we did not really formally introduce you ma'am, but I think Dr. Shalini Sinha and me, we have been working together for very many programs at Casey College. She is also coordinating the STAR scheme, and we work together wonderfully. And I think if you have good friends to work with, I think the every task becomes merrier. So thank you so much, Shalini ma'am, for always being with us, always motivating us, guiding us. And who could be better person for a valedictory address than you, as you yourself is so multidisciplinary in your approach. You are a chemistry graduate and a PhD in English. So thank you once again for being with us. We really, really appreciate all the time that you gave us. Then, of course, the resource persons. I'm sure everybody has spoken about them, and I'm sure you people have associated or communicated with them. But without Dr. Yogita Shinde, who set the ball rolling, or should I say the chalk rolling, by her lucid explanation of basic knowledge of chromatography on day one, which was then taken up by Mayuresh Joshi sir, who did hands-on TLC with cornstarch and gave us insights on HPTLC. And today's, of course, everybody and innovating, making hands-on especially we are doing these things online. So I think a big round of applause for all our management and resource people work very hard as well, you know. Actually, to prepare all this, how to bring it to you in the most effective manner. And yes, Suchismita, I do agree that we have left out a really good so definitely we'll take suggestions for our next whatever queries you have can be solved always. We are always with you. So next thing, of course, I wish all participants, especially all participants who actively participated, who also performed all the experiments and gave the positive feedback. I know there were no external participants speaking today, but I know you have been filling feedback every day, and I consider that as a very good feedback. So your feedback is already with us. So thanks a lot for that positive and engaging feedback. I wish to thank Dr. Sheila Valecha, who is the Associate Professor in Chemistry, who readily accepted to work with Life Science Department to have this interdisciplinary program. I'm sure all of you, those are from different colleges, especially the faculty members, they know how difficult it is to work together in synergistic manner. But I think the culture of KC is such that the doors are open from any lab to any lab, and the hearts are also welcoming and open. So thank you, Sheila ma'am, for being with us throughout for this one activity. I also wish to thank our tech team and with a day backup, this 3D streaming, online, live, Zoom, everything that was possible. So a big warm thank you goes to Monish and Roshan as well. And what would we have done without the student volunteers? Siddharth, can we have you on screen, please? Urvi, Anurag, Ria, Shivam, and Sonia. These are our backbones, without whom we could not have done anything. All this, please, I want you to come on the screen and these are our volunteers who took us, on this wonderful 3-day workshop come, demonstration exercise. I also wish to thank all our office staff and all the other staff. We went to college to get few things in between to organize for this workshop. So I want to thank each one of them for being there, for helping us out to make this a success or fruitful. So I'm sure this journey doesn't end here. I request all the participants, in-house as well as external, to feel free to contact our resource persons anytime, to contact us, to give us more ideas. And I'm sure that it is not just for the certificates that you all were here. You were here to learn, to grow together. And I'm sure that is what we have accomplished at the end of the day. Once again, a big warm thank you to all the dignitaries of the program, all the resource persons, all faculty members, and everybody. If I have missed out anybody, it's my fault. So please forgive me. Thank you so much. Thank you all students. Have a wonderful day. Stay safe and take care. Over to you. I think there is a feedback form posted in the chat box. Please do fill the feedback form. Thank you.
Thank you so much, ma'am. Participants, the feedback form is in the chat box. There are two feedback forms, one for today and one overall feedback. The link will remain open till 9 p.m. tonight. So please make sure that you fill the form. Thank you.
If I might
Can we
just add,
take a
host,
picture? Can we take a
host, if I
picture?
might
Can
just add,
some people can? Yeah.
ma'am, for all participants, please note that the link is same. Okay, though the feedback forms are two feedback forms, the link is same. So the link itself will take you through both day three feedback and the feedback for the overall workshop also. Okay, so please do complete the feedbacks and do not